Welcome to another QMI1500 tutorial session. This tutorial session is brought to you by KhaliTutors. If you haven't subscribed to our YouTube channel, please subscribe to get access to the latest videos the moment that we upload them. In this tutorial session, we are going to look at assessment number 2. Okay? Without wasting more of your time, let's just read the question and solve it. The equation of a quadratic function is given below. Y equals to f of x equals to 4x squared minus 8x plus 3. Determine the vertex coordinates, the discriminant of the function, the x-intercepts and y-intercepts that the parabola has. Choose the correct answer. So basically what you're supposed to do is do the calculations. Then once you're done, compare your answers to the answers provided here. Okay? Let's just minimize this to start answering the question. Okay, but before we can do that, I'm gonna take you through a very brief discussion of what a parabola is and some of its properties. Okay, so a parabola is a graph that looks something like this or something like this. A parabola has a turning point. Okay, a parabola has a turning point. The turning point can either be a maximum or minimum. Okay, if we are looking at graph 1, this is graph 1, the turning point is the minimum point of the graph. Okay, if we are looking at graph 2, the turning point, this turning point, okay, graph 2, the turning point is the maximum point of the graph. Okay. If you are given the standard formula or the general formula of a parabola, you can tell whether the graph will have a maximum turning point or a minimum turning point. Okay, a minimum point as your turning point, I mean. Okay, so a general formula or the standard form of the quadratic function is y equals to ax squared plus bx plus c. Okay, if you are given a function like this, you can use this value here to determine whether the graph will have a smiley face or a sad face. Will look like a smiley face or a sad face. Okay, what do I mean? So when this value here, when the value of a is greater than 0, when the value of a is greater than 0, the graph will look like graph 1 here. It will have a smiley face and the turning point will be the minimum point of the graph. Okay, if the value of a is less than 0, the graph will look like graph 2 here. The turning point will be the maximum point of the graph. Okay, so in our case we are given an equation, and the equation is y equals to 4x square plus minus 8x plus 3. Okay, this is the value of a here. So let me match this. This is a, this is b, so b is negative 8, not just 8, and this is c. Okay, so if you are given equations that make use of a, b, c, you just have to come here and realize that your a is the coefficient of x squared, and b is the coefficient of x, and c is the constant. Okay, so once you know this information, another important concept that you need to understand is the concept of intercepts. Okay, so generally when you draw a parabola, you will draw it on a Cartesian plane. Okay, you'll draw it on a Cartesian plane. A Cartesian plane looks something like this. Cartesian plane has an x-axis and a y-axis. So when they are talking about x-intercepts, they simply mean the points where the graph touches the x-axis. Okay, in this case, if this is our graph, let me change the color. Okay, if we had a graph like this one, okay, this point here will be x-intercepts. So the value of x here is what they want, or when they say they want the x-intercept. So that will be your x1, and then the value of x here, it's what they want when they're looking for x-intercept. So in this case, you have two x-intercepts. There are cases where you only have one intercept. For example, if we had a graph that looked like this, and then turned here, and then it only touched here at the turning point, here. Oh, that's the wrong color. Okay, so here we'll only have one x-intercept. So that means the graph will only touch the x-axis once. Okay, I hope that is clear. So the same principles apply when they're talking about your y-intercept. Y-intercept is when if you've got a graph that touches the y-axis. For example, let's say we had a graph like this one. Let me just write it here. We had a graph like this one which cuts the y-axis here. So this point here will be your y-intercept. Let's just say it's y1. So that's basically it when it comes to intercepts. Okay, your x-intercept, it's where the graph cuts your y-axis. Your y-intercept, I mean, it's where your graph cuts the y-axis. Your x-intercept, it's where your graph cuts what? The x-axis. Okay, so I think we're done with that. Then another topic that they are interested, another concept that they are interested in is the concept of discriminant. The discriminant of a function. So when they talk about the discriminant of the function, they mean let's say they mean the answer to this. Okay, so it's gonna be b squared minus 4ac. Okay, this is gonna be d. Let's just say it's d. Say this is the equation to determine your discriminant. If the discriminant is positive, okay, so you're using the discriminant to determine the number of x-intercepts. Please take note of this. You're only using the discriminant to find out the number of x-intercepts of a particular graph. So if the discriminant is greater than 0, that means the graph has two x-intercepts. Okay, has two x-intercepts. When the value of the discriminant d is equals to 0, that means the graph has only one x-intercept. Okay, when the value of the discriminant is less than 0, that means the graph has no x-intercepts. Okay, I hope that is clear. So since we've covered everything about intercepts, discriminants, and turning point, so your turning point here, when they say they determine the vertex coordinates, they want to find out the coordinates of your turning point. Okay, in this case, since it's clear that the value of a is greater than 0, 4 is greater than 0, we are expecting the graph to have something to look something like this. Okay, so what is the equation for determining the turning point? Okay, so to determine your turning point, the coordinates of the turning point are given by this equation. You will get your x value of the turning point by using the equation minus b over 2a. Where are you supposed to get the b and a from the standard the standard formula. So you know this is your A, this is your B. In this case, your A is 4 and your B is minus 8. So let's just substitute that, okay? Then we'll have x equals to minus brackets minus 8, okay, over 2. What is the value of A is 4. Getting that 4 from here, okay, 4. And then we have what? So if you negative multiply by negative, this is like it's the same as having minus 1 here. Negative multiply by negative, you get positive. Then this becomes 8 over 8, which becomes 1. Once you have, this is the x coordinate. This is the x coordinate. Remember that. Once you have the x coordinate, what you do is you take the value of x, you substitute it to the original equation, and you get the y value of the turning point. Okay, so what we're gonna do, we're gonna say y equals to, we're taking the standard equation, this one, the equation that we are given, 4. Instead of writing x, we're gonna write the value of x, since we know 1, and then square minus 8, then 1, then plus 3. Okay, this will give us this will be 4, this will be 4. Okay, so this one is 4 minus 8 becomes minus 4 plus 3 becomes minus 1. So we know the y value, we know the x value. So at the turning point, the coordinates are x is 1, y is minus 1. So this is your vertex coordinates, right? Vertex coordinates. Okay, so we have dealt with the first part. Okay, now we're supposed to determine the discriminant. Okay, the discriminant is given by the equation. Okay, this is gonna be messy here. The discriminant is given by this equation: d equals to b squared minus 4ac. Okay, we know that b is minus 8. Then we're gonna write minus 8 square. Then minus 4. 4 is part of the equation. Then what's the value of a? It's 4 as well. And then the value of c is 3. Okay, then you take out your calculator and you calculate. Okay, let me calculate this because I haven't done so myself. Where's the calculator? Okay, and the value here, okay, I'm giving you time to do the calculation yourself as well. So okay, b is minus 8 square minus 4 times 3, or it becomes 16. Okay, then the value is the answer is 16. Okay, so we have our discriminant. Our discriminant is 16. Now we need to determine the x-intercepts. Okay, because we know that the value of the discriminant is 16, and 16 is greater than what? Is greater than 0. We know that this function has 2 x-intercepts. Okay, this is what we discussed. This is what we discussed here. If the value of d is greater than 0, the parabola has 2 what? Intercepts. Okay, so we know that information. So let's continue now. Okay, let's continue. Let me leave the cursor there. Okay, how do we go about it? We know that, okay, since we know we have the equation, which is y equals to 4x squared minus 8x plus 3. We know that the x-intercept y is equals to 0. Then we're gonna substitute 0 here, equate that to 4x squared minus 8x plus 3. Okay, so I hope all of you are able to factorize. You simply have to factorize this. Okay, Then I'm just gonna say 0 is equals to okay, I'm gonna factorize this. So when you factorize something, make sure that if you multiply out, you get the same answer. Okay, so here it's gonna be 3 and 1. I'm looking at the factors of 3 and 1. What are the factors of 3? So if I need this value here to have a positive sign, I need to have, it's either I have plus plus or have minus minus. Since this value here is negative, I must have minus. Okay, minus both sides. Okay, then I need to make sure that whatever I factor this side and this side, when I do the multiplication, I get this value here when I sum the factor, or what do I call it? Let me not just say a lot. Let me just write this. Okay, so I know what I'm doing. Okay, so I hope all of you are able to factorize. This is great and stuff. But if you're not sure how to factorize, you can send us a text and then we'll explain to you. Okay, so yeah, so I need to check if this will really give me this. Okay, I'll have to say 2x multiplied by 2x multiplied by 2x, that will give me 4x square. 2x multiplied by minus 3, that will give me minus 6x. Okay, minus 1 times minus 2, that will give me minus 2x. Okay, it does give me the answer. Okay, so these two, minus 6x minus 2x, gives me minus 8x. So as you can see, it goes back to the original function. Okay, so once you're done with this, you're not done. Okay, so let's continue with this. We're gonna continue here. It's gonna be messy, like I said. We're gonna continue here. So this simply means, okay, for this whole thing to be 0, it's either this whole, let me change the card. For this product to be 0, it's either this here is equals to 0, or this here is equals to 0, or they're both equals to 0. Okay, so we just have to take this and equate this to 0. So for this to be 0, we have 2x minus 1 equals to 0, or 2x or 2x minus 3 is equals to 0. Okay, and then we solve these two. This is 2x minus 3 equals to 0. If you solve this, you will have 2x equals to, take this one to the other side, it becomes 1, and then divide both sides by 2 to get x. Divide by 2, divide by 2, then you have x equals to 1 over 2. Okay, and then let's solve for this one. Here you have 2x minus 3x equals to 0. You will have 2x equals to, take this 3 to the other side. Okay, it changes the sign, it becomes positive. Then you have 3. Then to get x, you divide by 2. You divide by 2. Then you have x equals to 3 over 2. Okay, so x equals to 1 over 2. 1 over 2 is the same as 0.5, and 3 over 2 is the same as, okay, x equals to 1.5. okay, this is x. So this in terms of coordinates, this is like your x will be 0.5, y is 0, and here your x is 1.5 and y is 0. Okay, so what else is missing? Okay, the only thing that's left to do now is the y-intercept. Okay, we still have to determine the y-intercept. So I'm going to delete some of these things here. Okay, I'm going to delete this so that we can have some space. Let's delete that. Okay, I've deleted. So we only we need to determine the y-intercept now. So to determine the y-intercept, you simply do the same thing that you just did for x-intercept. We know at the y-intercept x is equals to 0. So we take the function as it is, y equals to okay, it's 4x squared minus 8x plus 3. Then we substitute 0 where there is x. Okay, then we'll have y equals to 4 times 0 square plus minus 8 times 0, okay, plus 3. So this one becomes 0, this one becomes 0. Then the y-intercept is equals to 3. Then in terms of coordinates, you'll have your x is 0 at the y-intercept and y is 3. Okay, so we're done with this question. Now we need to check and compare and see if there is any option that has the same answers as us. And then if you look at the first option here, we got this one as the turning point. Where is it? Did I delete it? Oh, it's here. That's the first one, the turning point. And then we got the discriminant, which is 16. Where is it? It's here. Okay. Then the x-intercepts, we have 0.5, which is this one, 0.5, and 1.5, which is this one. So this one is correct. And and lastly, the y-intercept is this one. So the correct answer for this question is this one here. Okay, I hope this video has made things clear to you. Thank you for watching.